Just wait. Okay. Okay, so I will share a video later. Okay, let's go to the notes. I think your exam yeah, will held from July 20. I have heard like that, but not sure. Okay, but it may happen from it will held from 20 July. Okay. Yes. Given. And it's not officially given. That's why we have not shared. Officially, they told that is the provisional one, so don't share like that. You got okay. So basically, objective question will come in your exam. Okay. So nothing much to it will not difficult for you. I think so, isn't it? So all the subject will be optional. All the questions will be optional. So last parts of children, I think last class we have discussed, isn't it? And these are the use of theodolite. Following are a different purpose of using theodolite for measuring horizontal angle, for measuring vertical angle, deflection angle, magnetic bearing, and measuring the horizontal distance between the 2 points, finding vertical height of an object. Okay, can the sound is disturbing nearby? Uh, there are some doing work. Measuring the horizontal distance between the 2 points, finding vertical height of an object, finding difference of elevation between various points, and the ranging of a line. Next, types of light we have discussed transit and non-transit, isn't it? So these are the different parts of the light. It has vertical scale, telescope, upper plate, lower plate, horizontal scale, upper scale, lower clamp, sorry, upper clamp, lower clamp, circle reading, and optical micrometer, index bar. So important terms related to light, that is your centering, transiting, face left, face right. Okay. What is centering? The setting the theodolite exactly over a setting the theodolite exactly over a station marked by means of a plumb bob is known as centering. Transiting, the method of turning the telescope about its horizontal axis in a vertical plane through 180 degree is termed as transiting. In other words, transiting results in a change of phase level. It means that vertical circle of tail light is on the left of the observer. Okay. Phase right means it is the situation when vertical circle of the instrument is on the right of the observer when the reading is taken. Changing phase, the operation of bringing the vertical circle from one side of the observer to the other is known as changing phase. Swinging the telescope, it indicates the turning the telescope in a horizontal plane. If you rotate the telescope in a horizontal plane, that is your swing. Line of collimation, it is an imaginary line passing through the optical center of objective, glass and its collimation. Axis of telescope, which is the axis of imaginary line passing through the optical center of the object and glass and the optical center of eyepiece. Next, uses of theodolite. So, theodolite is for measuring horizontal angle. The procedure is given here. PQR is the angle, PQR at station Q. The process of centering, leveling, and focusing are called temporary adjustment. So, how to measure? Set the theodolite at Q point with vertical circle to the left of the line of sight and complete all the temporary adjustment. Release the upper and lower clamp and turn upper plate to get 0 degree on the main scale. Then clamp the main screw using tangent screw, get exactly 0 reading. At this stage, vernier V reach 0 and vernier V reach 180 degree. Through telescope, take the line of sight to take a point P and lock the lower clamp. Use tangent screw the exact bisection. Release the upper clamp and swing telescope to bisect the. Generally, before taking the measurement, you should know how to rotate the telescope, how to uh, use the telescope. Okay, it should be properly level. Otherwise, there may be lot of errors. Read the vernier A and B. The reading of vernier A gives desired PQR directly, while 180 degree is to be subtracted from the reading vernier B to get angle PQR. So whatever you have uh, shown the reading in vernier scale, you just subtract it from 180 degree and that will give your angle PQR. So there are some scale, vernier scale, which shows the angles. The average four values found for theta gives the horizontal angle. Two values obtained with face left and two values of face right position of vertical are called one set of reading. Okay, then this process is called method of repetition. If more precision is required, angle may be measured repeatedly. That is, after step 5, release lower clamp, sight signal at P, then lock the lower clamp, release the upper clamp, and swing the telescope to signal at Q. The reading of vernier A doubles, the angle measured by vernier B is also double, and any number of repetition may be made and average taken. Similar readings are then taken with face right also. Finally, average angle is found and is taken as desired angle Q. This is called method of repetition. Okay, measurement of vertical angle. Horizontal sight is taken as 0 vertical angle. Angle of elevation are noted as positive angles and the angle of depression as negative angles. Axis of theodolite is this one. These are the axis of a theodolite. Vertical, okay, these things already I have some. I'll share. And main principle of theodolite is traversing. Okay, what is purpose of traverse? In a convenient, rapid method of establishing horizontal control, particularly when the lines of sight are short due to heavily built up areas where triangulation and trilateration are not applicable. The purpose includes property surveys to locate or establish boundaries. Okay, these are the traverse already you know. And there are some important points regarding light, and these are your latitude and departure. Latitude and departure. Okay, important. What is latitude? Latitude is the north-south component of a line. Departure is the west-east. So these are the direction actually. North latitudes are positive and south are negative. So for that you should know the diagram. That is north, that is south, that is east and west. So here south is negative, you know already, and north latitudes are always positive. Similarly, east departure are positive and west are negative. So already in compass traversing, you know the quadrant and what are the symbol sign positive, where are the positive signs and negative signs lies. So this line is called departure and this west south line is called your latitude. Okay, latitude and departure are computed from let equal to length into cos, departure equal to length whatever it may be AB length, suppose AB sine theta, and in latitude it is AB cos theta, like that. We have to measure. Because a bearing angle never exceeds 90 degree, the latitude and departure equation will always return positive values. So these are the symbol of latitude and departure. In this quadrant, latitude is positive, departure is also positive. Here, latitude is negative, departure is positive. Isn't it? These are important because you see, you should know the departure. This figure, you should remember this figure. So this way departure, this way latitude. So this is the departure, this is the latitude. Here departure is also negative, that was also negative. This is the departure, this is the latitude. This is the departure, this is the latitude. Okay? Okay. So these are the directions showing latitude and departure, and departure is given as L and latitude is L cos theta. L, as I have already told you, departure latitude is measured. L is the length and theta is the angle between the two lines. Okay. So departure is equal to L cos theta. Okay. So measuring the closing error, calculation of closing error. In a complete circuit, the sum of the north latitudes must be equal to the sum of the south latitudes. The sum of easting must be equal to that of wasting if all the measurements are taken. If not, the distance between the starting portion and the position obtained. I think you have got disturbance, isn't it? The sound noise problem. If not, the distance between the starting portion and the position obtained by calculation is known as closing error. For example, let's assume that the sum of northing traverse exceeding is equal something by 1 meter and that and that. So your resultant closing error will be root over 1.8 square plus 1.5 whole square. Right, to 2.34. The closing error is generally expressed as fraction and is given by closing error perimeter of the traverse. Let perimeter of the traverse equal to 1000 meter. So closing error will be your suppose 2.34 divided by 1000 where n is 1000. Okay. Balancing the consecutive coordinates. The process of adjusting key coordinates of each line by applying correction to them in such a way that algebraic sum the latitude and departure closed circuit should be equal to 0. So balancing the consecutive coordinate means summation of departure will equal to 0 and summation of latitude should be 0. And if the above condition are not satisfied, the position A of the origin station and its computed position A days will not be same as shown in the figure due to the observation error. The distance AA between them is known as closing error and it is given by E equal to summation of departure whole square plus summation of latitude whole square. And the angle and its direction is why they are joining so late? Let them wait. So n is direction and reduced bearing is given by tan theta equal to summation of d divided by summation of L. The term balancing is generally applied to the operation of adjusting the closing error in a closed traverse by applying correction to the departure and latitude. So there are some rules. One is called Bodditt's rule, Bodditt's method, where CD are the correction you can find out from this equation. CD equal to summation of departure into L by summation of L, where CD and CL are the correction of the departure and latitude of the line which it is applied, and it is called L is if L is the length and length of L is the length of line and summation of L is the sum of the length of all the lines of the traverse, that is perimeter P. And another is transit rule. According to this rule, the corrections to the latitude of a traverse leg is given by total error in latitude into latitude of that traverse leg into total sum of latitude. CD equal to summation of D into small d by d. And another is graphical method that is not required. Tachyometric survey. Okay, after that we have another important topic that is your tachyometric survey. Okay. Tachyometric is another part of surveying in which horizontal and vertical distances are determined by taking angular observation with an instrument known as tachyometer. Tachyometric survey is adopted in rough and difficult terrain where direct leveling and chaining are not possible. Tachometric survey can be used for railways, roadways, reservoirs, etc. Tachometric survey is very rapid. A reasonable contour map can be prepared by investigation work within a short time on the basis of such survey. An ordinary transit theodolite fitted with a stadia diaphragm is generally used as tachometric surveying. Okay. The stadia diaphragm essentially consists of one stadia here above and another and equal just below. So these are the stadia here. Other is equal distance between the horizontal crosshair and steady hair being mounted in the same ring and is. So these are the crosshairs. Advantage of tachometry, since both the quantities, that is horizontal distance and vertical distance, that means difference in elevation, are determined indirectly in tachometric survey. It has a number of advantages over direct method of measurement and disadvantage. In terrain where direct methods are not convenient, tachometric method can be used. Tachometric methods are more convenient for reconnaissance survey of routes, for hydrographic survey, and for filling in details in a traverse. There is considerable saving of in time and money with the use of tachometric methods. How it can be used. Tachometry is used for the preparation of topographic map where both horizontal and vertical distances are required to be measured. Survey work in difficult terrain where direct methods are not applicable. Reconnaissance survey for highways and railways, etc., and establishment of secondary control points. Okay, so there is a basic formula for determination of horizontal distance in stadia tachometry, that is d equal to f as divided by I plus f plus c. That means d equal to ks plus c. So we have we have one multiplying constant k and we have one additive constant c. Okay. Okay, so due to the presence of these additive constants, C and D is not directly proportional to S. This is accomplished by introduction of additional convex lens to the telescope. So it uses simplifies the reduction of additive constant. Your F plus C is made to zero. This line is important. Okay. It uses simplifies the reduction of observations since the additive constant f plus c equal to 0 and multiplying constantly is 100. So in exam it may ask what is the additive constant? What is the value of additive constant? Then it is 0. What is the value of multiplying constant in tachometer? So it is 100. Okay. Okay, different system of tachometric measurement, fixed hair method and movable hair method. These things are not important. I will not discuss. Stadia system consider two methods. These are the two methods. One is fixed hair method, another is movable hair method. In fixed hair method, what will happen? The steady hairs are kept at fixed interval and staff interval or intercept. Staff intercept depends upon the distance between the instrument station and staff. In this method, the distance between the upper hair and lower hair, that is stadia interval I, on the diaphragm of the lens system is fixed. The staff intercept S is therefore changed according to the distance D and vertical. Okay, in movable. Okay, the movable hair method is rarely used. Okay, and another method is tangential method. Substance bar system. Principle of stadia method. Okay. So this is the equation of stadia method. K is equal to F by I is called multiplying constant of the tachometer and generally 100. The value of Fi equal to 100. F divided by equal to 100 and the constant C is equal to F plus C, which is called additive constant, and that is 0. Tangential methods. This stage you study yourself. Okay, another chapter left, that is your curve survey. So in curve surveying, that is also used for railway. Curve surveying generally used for railways, for laying railway lines. Okay, for railway lines in highways also. Okay, let's see the definition. Okay, the center line of a road consists of a series of straight lines interconnected by curves, isn't it? So, in a road system, we have different such type of turning, isn't it? And these turnings are generally provided with the help of curve survey, both in railways and roadways, that are used to change the alignment, direction, or slope of the routes. Those curves that change the alignment or direction are known as horizontal curves, and those that change the slope are called vertical curves. When a highway changes horizontal direction, making the point where it changes direction in a point intersection, okay, the straight line of a road are called tangents because the lines are tangent to the curves used in changing direction. Horizontal curves are further classified. So, horizontal curves, what is horizontal curves? These are those curves that changes the alignment of a direction. So, these horizontal curves are classified as circular curves and transition curves. Two main classification of horizontal curves is circular and transition curves. A curve may be simple, compound, reverse. A curve may be simple curve, compound curve, or it may be reverse or spiral. Compound curve and reverse curves are treated as combination of two or more simple curves, where a spiral curve is based on varying radius. So simple circular curve, this curve is an arc of a circle. It is most commonly used. The radius of so simple curve is most commonly used. The radius of circle determines the sharpness of the curve. The larger the radius, flatter will be the curve. Okay. So next is compound curve. So it is a combination of two or more simple curves. Okay. This is another simple curve which have very different radius, and it combined with another curves and it meet at a point with, and it has also different radius. T1 and T2 are a tangent. Okay. These curves normally consist of two simple curves curving in the same direction and joined together. Next one is reverse curve. They have different radius and opposite in direction. Okay. A reverse curve consists of two simple curves joined together but curving in opposite direction. Next one is spiral. The spiral curve is it also have different radius. On railroads and some modern highways, it provides a transition curve from the tangent to a simple curve or between the simple curves. Okay, next one is your elements of simple curve. So in this figure, it has shown different elements of a simple curve, and this is very important. So in a curve, it has a tangent, one radius, one origin, isn't it? This is your suppose origin. So from here, this is your curve, isn't it? So L is the curve length. D is the middle of the curve. It has mid ordinate T. And this is the tangent. Again, this is another tangent T2. It meet one. It meets at one point. This is called point of intersection. Okay, this is the central angle, and it is denoted by, this is the angle, central angle, it is delta. And this angle is denoted by delta by 2. This is delta by 2, isn't it? So this one T2 is the forward tangent and T1 is called the back tangent. This is the point of curve. This is the deflection angle delta, and this is the apex distance. This distance is called apex distance. So these are the different elements of a simple curve. Okay, the definitions of these elements are given here. Just one second. So these are the different definitions are given. Degree of curve, arc definition, chord definition. Degree of curve is generally defined by two ways. One is arc definition, another is chord definition. Sorry, chord definition. Definition of arc definition, degree of curvature is defined as angle in degrees subtended by an arc of standard length shown in the figure below. So these are the two arc definitions. This one is arc definition, this one is chord definition. This one is your arc, isn't it? So this is the degree of chord, and this is chord definition. This one is your chord. So this one is a chord definition. Okay, so there are some important formulas. So I will discuss this later. Okay, all of you write down your enrollment IDs. Yiba, Suraj, Bora, Johnny, Ki, John, Clary, and Ductim. Yes, finishing the class. After now, just now. Yes, yes, I have not shared. I think in chat box I cannot share, isn't it? So I have. Okay, I will give. Okay, I will give. Now only I will give. Okay, write down your enrollment IDs. I will send right now. Mm. Because exam is coming, na. You have to study also. Iba, why are you waiting in the lobby? Why have you not joined as soon as the car class started? Okay, everyone have written your enrollment IDs? Okay, I'm going to share my notes to Seer and they will share with you. Okay? Thank you.